After the successful execution of the Chandrayaan-3 mission, ISRO, Indian Space Research Organization, has set its sights on the Sun, India's Aditya L1 solar mission to launch on September 2, 2023. Before diving into the mission and its objective, we need to understand why we need to study the Sun. The Sun, being the nearest star, is a prime target for studying its dynamic nature, which includes eruptive phenomena and energy release. These events can have a significant impact on Earth's near-Earth space environment, so early warning of such occurrences is crucial for minimizing disruptions to communication systems and other spacecraft. Studying the Sun in its natural environment offers a unique opportunity to understand phenomena that cannot be replicated in a lab. Lagrange points are stable locations around a planet's orbit where spacecraft can be stationed for observations. There are 5 L points, named L1, L2, L3, L4, and L5, with L1 being 1.5 million kilometers from Earth and 1% of the Earth-Sun distance. The Aditya L1 mission is the first space-based observatory-class Indian solar mission. The spacecraft will be placed in a halo orbit around the L1 point because it offers the advantage of constantly observing the Sun without interruption due to occultation or eclipse. This will provide more consistent and continuous observations of solar activities. Aditya L1 will carry 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun, the corona, using electromagnetic and particle detectors. 4 payloads on board Aditya L1 will directly view the Sun, and the remaining 3 will carry out in situ studies of particles and fields at L1. The 7 scientific payloads, Visible Emission Line Coronagraph, VLC, studies solar corona and dynamics of coronal mass ejections, Solar Ultraviolet Imaging Telescope, SUT, images the solar photosphere and chromosphere in near ultraviolet and also measures the solar irradiance variations in near UV, Aditya Solar Wind Particle Experiment, aspects, and Plasma Analyzer Package for Aditya, PAPA, payload study the solar wind and energetic ions, as well as their energy distribution. Solar Low Energy X-ray Spectrometer, SOLEXS, and the High Energy L1 Orbiting X-ray Spectrometer, HEL1OS, study the X-ray flares from the Sun over a wide X-ray energy range. Magnetometer is capable of measuring interplanetary magnetic fields at L1 point. The journey, Aditya L1 will be placed in a low Earth orbit by ISRO's PSLV C-57 rocket. Subsequently, the orbit will be made more elliptical and spacecraft will be launched towards L1 point by using onboard propulsion. As the spacecraft travels towards L1, it will exit Earth's gravitational sphere of influence, SOI. After SOI exit, cruise phase will start and craft will be injected into a large halo orbit around L1. It will take 4 months for the spacecraft to reach its destination. Mark your calendar, September 2, 2023 at 11:30 a.m. IST.